Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have listed the first 20 elements according to the atomic numbers. I hope you have memorized all that list, the members present in that list. Today we will be seeing how the electrons are arranged in the atoms of these various elements. So there are some rules regarding the arrangement of electrons. Okay, so as we have already discussed that electrons are present in the orbits or shells around the nucleus of an atom. Now, if a atom has 20 electrons, it is not such that all the 20 electrons will be present in one orbit or shell. They are distributed, and there are certain rules that we can use to find out the distribution of the electrons in the various shells. Okay, so we will be taking some examples. If we consider the element having an atomic number, okay, first there is one rule that I would like to relate. It's the Bohr-Bury rule. Okay, so first just note down the rule, then we will see how we are applying these rules. Bohr-Bury rule. What does this Bohr-Bury rule says? See, basically the orbits around the nucleus of the atoms are numbered as 1, 2, 3, 4. Also they are lettered as K, L, M, N, like this. The first shell or the innermost shell, which is nearest to the nucleus of the atom, is regarded as the K shell. Then after that comes the L shell, likewise K, L, M, N shells. Okay. So what does the Bohr-Bury rule says? If we consider the nth orbit, okay, so if we consider the nth orbit, so for nth orbit means you can consider the first orbit, second orbit, third orbit, like this. Nth orbit, the maximum number of electrons that can be present in that shell is given by the formula 2n square, where n is the number of the shell that you are considering. Okay, so 2n square. So if I consider the first shell can have a maximum of, so for example, if we just consider the first shell, then the first shell can have a maximum number of how many electrons? 2 into 1 square, that is 2 electrons. Second shell can have maximum number of 2 into 2 square, it's 8 electrons. Like third shell can have maximum number of electron 2 into 3 square, that is 18 electrons. Likewise, the various shells will have various number of electrons. Okay, fine. So considering this, we will be getting 2, 8, 18 electrons respectively. Remember, this is the maximum number of electrons that can be accommodated in the respective shell. Less number of electrons other than this can be accommodated. If I consider the third shell, any number of electrons less than 18 or up to 18 can be considered. Okay, fine. Now how we utilize this rule? There is another rule. So this is the first rule, the Bohr-Bury rule. Please note it down. If you have not paused the video, note it down. There is another rule. The second rule comes. This is the first rule. The second rule says, what does the second rule says? The second rule says that the last orbit is called the ultimate shell. Okay, ultimate shell, as well as okay, the penultimate shell. Which is penultimate shell? the shell which is just before the ultimate shell, okay, penultimate shell, can have maximum of 8 electrons. Okay, so this is the another rule. Now there are exceptions to this rule, but in general the electronic configuration of the first 20 elements that we are considering for our class will follow these two rules. So is it clear? Okay. Now let us apply these rules and see how the electronic configuration stands out. Okay. So I am just listing it off. So if I consider the first element, that is hydrogen. If I consider the first element, hydrogen. So hydrogen has an atomic number of 1. Hydrogen has an atomic number of 1. So how the electrons are distributed? There is only one electron and it can be easily accommodated in the first shell. So if I just note down the shells here, so it's K shell, L shell, M shell and N shell. So these are the cells, first, second, third and fourth. Fine. Now if you consider hydrogen atom, it has only one electron as the atomic number is 1. So it will have only one electron in the K shell. Likewise, if I consider the second element, helium, helium has an atomic number of 2. So it has 2 electrons. So definitely for the first electron can accommodate a maximum of 2 electrons. So there are 2 electrons only. So just put it in the first shell. If I consider the third element, hydrogen, helium, then it's lithium. Lithium has an atomic number 3. So we consider 3. The number of electrons is also 3. So there will be 2 electrons in the first shell. The first shell cannot have more than 2 electrons. So where will the third electron go? It will just simply move on to the L shell. So it looks like this. Okay, so there are 2 electrons in the first shell and the 1 electron in the second shell. Okay. Then comes hydrogen, helium, lithium. Then comes beryllium. Beryllium has an atomic number of 4. So if we consider 2 electrons in the first shell and put the remaining 2 electrons in the second shell. So 2, 2. Then comes the fifth, hydrogen, helium, lithium, beryllium, boron. So it's only B, boron. Fifth, okay, atomic number 5. So how many electrons does it have? 5 electrons. Put 2 electrons in the first shell and then 3 electrons in the L shell or the second shell. So like this you get the electronic configuration of the first 5 elements. Now something you must note here is that this helium is a noble gas. I will be just denoting the type of elements. Okay, this helium is a noble gas. I am just marking it with red color. Okay, helium is the noble gas. Is a noble gas. I will be marking the noble gas with red color because of special reason. Noble gas. Noble is a kind of non-metal you can consider. So it has only 2 electrons in the outermost shell. Okay, fine. This is called duplet structure. Duplet structure. Okay, what it is called? It is called duplet structure. Okay, duplet structure. Now lithium and beryllium, okay, lithium and beryllium, these are regarded as what? These are regarded as metals. Boron is also to some extent metal. So these elements are metals. Okay, these elements are metals. Now you can consider, and the hydrogen is a non-metal. Okay, so from this configuration you can see one thing common is that metals have either 1, 2 or 3 electron in their last shell, whereas the noble gas has just 2 electrons in the last shell, whereas the non-metal has only 1 electron in the last shell. Okay, now if we further see the electronic configuration of the other elements, consequently we will see some more patterns. Okay, so today we will be stopping right here. In the next class we will be discussing about the electronic configuration from the next elements, and we will find out some general pattern and then you can make some conclusions. Okay, so till then the next video will be uploaded and you will be further seeing how these elements, how the electronic configuration is related to the nature of the element. Okay, so till then please study this part. If you have any inquiry, mention it in the comment box. We will be happy to solve the problem. Thank you. Goodbye.